Hi everyone, time for the big one, Target 8, how the sun's electromagnetic radiation causes global wind belts, convection cells, pressure belts. It's only the beginning. Well, let's do a little review. Why do we have wind on Earth? Dun dun dun. Why do we have different air pressures? It's because our Earth is unevenly heated. You got that right. So put it all together. This is what you need to know. Cause and effect and effect and effect and effect and effects. Yes, the Earth is unevenly heated, creating differences in air pressures. Those differences in air pressures create convection cells that move air in the north and the south hemispheres. And due to the Earth spinning, we're going to end up getting 3 convection cells in each hemisphere instead of 1. Well, this also creates the 6 surface wind belts, 3 in the north, 3 in the south hemisphere. And in between the wind belts are the pressure belts, ta-da, which are caused by the Earth being unevenly heated. But, gotta love the but, due to the Coriolis effect, which you learned about, the surface winds in the northern hemisphere seem to turn to the right, and in the left in the southern hemisphere, which affect our surface winds. So what will you need to do? Be able to draw, label, and explain all of this material and show it with arrows on paper. It's the best. Cause, effect, 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 effect. So number 1, the equator gets the most solar energy, the most heat throughout the year. So air on the equator rises. What type of pressure will you end up with on the equator? If you said low, you're awesome. At the poles, generically, is the coolest air year-round. Air will be descending, going to the north and south pole. When air is being added to the surface, what type of pressure do you get? High pressure. So basically, we're going to get a huge convection cell in the north and a huge convection cell in the south. Aha, and I did that over here with my sweet, sexy arrows. But that would be nice, except the Earth does rotate or spin. So here's a better picture maybe showing huge. This would go all the way around, once again, from uneven heating. But the Earth spins, so instead of 1 huge in the north and 1 huge in the south, it ends up being twisted and broken into 3 in the north. See a convection cell? And another convection cell? And then our third. Now this would go all the way around the planet. And I tried to put in some lines there. Maybe this picture is better. So this convection cell is like all the way around in between the red lines there, basically. All because the Earth is spinning due to the Coriolis effect. So let's add in our pressures. Air is leaving, low pressure. Air is being added, high pressure. Air is leaving, low pressure. Air being added, high pressure, etc. Those are our generic pressure belts that are approximately on Earth at those locations throughout the year. Okay, now let's take those pressure belts and create the wind. Wind always moves from high to low. Aha. So if it's low pressure at the equator and high pressure here, air will be moving from high to low. From high to low. Okay, now we're going to take these surface wind movements and we're going to turn them due to the Coriolis to the right in the north or left in the southern hemisphere. And I'll show you how to do this with paper so you never screw up in class. So it should be going in a straight line from high to low, but it seems to turn to the right. It goes from high to low. You better turn your computer upside down because it goes to the right. It looks like it's turning to the left, but if you're driving a car along this path, you're facing to the right, it turns. And the opposite in the southern hemisphere. Okay, we got it all on there. Now all we got to do is label the wind belts based on their direction. Wind is named from the direction it blows from. Okay, so ta-da, this area is going to be called the southwesterlies, the prevailing westerlies, the northeast trade winds, okay, etc. I got all the names on here. We'll be using a map just like this in class. It's also in your book, so you can also see it here. These are the westerlies. We often call them from the southwesterlies. They could be the westerlies or the northwesterlies, but whatever. And it's got everything. If you want a little fun fact, the polar jet stream or the polar front is the boundary between the polar easterlies carrying cool air and the westerlies, which often carry warmer air. So in the winter, when we get all those polar vortexes, it's when this boundary is pushed further south than us. This is awesome. In review, you got to be able to draw, label, and explain all these things. In other words, why the Earth has global convection cells, currents, pressure belts, and wind belts. You can do it. We will practice in class, so bring lots of paper. Love you, have fun, and keep learning.